Hi guys, today we're going to take a look at page 12 of the Unit 7 Classwork packet, and we're going to take a look at how to deal with cases where we have three parallel lines cut through by two transversals. Oh my god, it sounds so scary, doesn't it? Well, guess what? It's actually not, because it's exactly the same theorem, just with different vocabulary, as the triangle proportionality theorem. In other words, all we need to know is that piece over piece equals piece over piece. To show you guys what I mean, let's take a look at example number 10, okay? So example number 10 does this. They give me three parallel lines. I know they're parallel because guess what? They told me that using the arrows. And then they have one transversal and they have another transversal, right? So this right here is 45. This is 18. This is 52, and this is x. The way that I approach this problem algebraically is to set up two proportions. This to this equals this to this. So I'm going to say piece 1 to piece 2, 45 over 18, equals this one over this one. Now, before we actually move on, notice that I can simplify using a GCF. There's a GCF of 3 that goes in here, so I'm going to turn that into 15, and I'm going to turn that into a 6. But it turns out that actually wasn't a GCF. The GCF is actually 9. Sorry about that. So I do another GCF of 3, and I get 5 over 2. Sorry about that, guys. So my new equation actually is 5 over 2 equals 52 over x. Do you guys know how to solve proportional equations? Yes, you do, by using cross multiplication. So in this case, look at that. 5x equals 104, and all I have to do is divide both sides through by 5. Now, some of you guys are kind of like scared of decimals, but there's no need to be. Let's work this out together. 5 goes into 10 twice, right? Does 5 go, we'll bring down the 4. Does 5 go into 4? No, so I put a 0. Then I put a decimal, bring down another 0. Does 5 go into 40? Yes, it does. All right. Some of you guys could have also done that as a mixed number. You could have done it as, for example, what would that be, 20 and 4/5? And that would work too, all right? But in this particular case, your answer is actually 20.8. Looks a little weird, but guess what? It's actually right, all right? Now, let's take a look at one more example, just to make sure you guys are okay. Where is my eraser? There it is. And that example is going to be number 13. All right. All right. So, let's take a look. Number 13 looks pretty... Talk about Butterfingers, right? Number 13 looks pretty similar in that they give me three parallel lines, okay? I've got two transversals, like so, and they tell me this is 28, this is 31.5, this is x, and this whole thing here is 92. Okay, so in order to find my other piece, guys, what would I have to do with the 92 and the 28? I would just have to subtract them. So 92 minus 28, that's going to become a 12, and I have to borrow, so I get 64. So now I have all the information that I need in my diagram in order to be able to move ahead with piece over piece equals piece over piece. Okay? So 28 over 64 equals 31.5 over x. Now, notice something here. I can simplify here using a GCF of 4, right? So this is going to become 7 over 16. Did I do that right? Yeah, 7 over 16. And now I'm ready to cross multiply. So 7 times x equals 16 times 31.5. Let's actually work that out the long way. 0, 3, 9, 18, 0, 5, 1, 3, 0, 4, 10, 5, 1 decimal, and so I get 504. Divide both sides through by 7, and let's see what I get, okay? So 7 goes into 57 times. 1, bring down the 4, 72. All right, so in this particular case, x equals 72. Again, normally we group this particular theorem together with triangle proportionality theorem because the method you use and the setup are exactly the same. If you guys can remember, piece to piece equals piece to piece. And notice here I did top to bottom, all right? I could have also done bottom to top, but you just got to make sure you're consistent. These will be some of the easiest problems that you see on your Unit 7 test, and potentially maybe like a pseudo EOC question as well.